shop and then continue here without having a sequence flow here. So sequence flows need to be present still in all of the processes. And collaboration diagrams are basically interaction models, or in the category of interaction models, interconnection models, because they simply interconnect all the different participants that are involved in the choreography. So, is notation clear? And I can continue with this. The issue with that representation is that, as you can see, it's quite complex. It's large. It's quite hard to really coordinate interaction behavior when you have interactions all over the place here and so many different tasks and events. And this is due to two reasons. The first reason here is that we currently look at a so-called private process of one of the, or two actually, of the collaborators. And in the private process view, we also include activities, events, decisions, whatever, that are not visible to other participants, because a customer cannot see when an online shop is checking the inventory. On the other hand, other tasks where we send or receive messages, they are also visible to other participants. So here we differentiate between two different types of tasks, which are process internal tasks and also externally visible tasks. And for the private process, we can also include them, but for simplicity, since we only want to coordinate interaction behavior, we can simply remove them and now only cover the process behavior that can be observed by other participants. And this is called the public process. While it's already a bit less, a bit simpler, still we have some complexity in collaboration diagrams due to redundancy. Because here, for each interaction, we have always task, sending task or sending event, and we have a receiving event or receiving task. And in addition to that, we also have redundancy in decisions that we take. So, for example, here, this decision also needs to be represented somewhere here in this example. And since this is, again, some complexity that needs to be considered when we really try to create some collaboration, a new type of diagram has been introduced by BPM, which is called choreography diagram, to simplify that situation. But for collaboration diagrams, I hope everything's clear. Okay. So the new type of diagrams is called choreography diagrams. And in contrast to collaboration diagrams, where we really also have some processes of the collaborators, this type of diagram only focuses on the interactions that take place. So they have some kind of global perspective on the entire collaboration that we have. And they can also be seen as a behavioral contract between those participants, because as I already told, in the process choreography, we want to define the sequence and the constraints of how participants can interact. And there is one new element that can be used for choreography diagrams, called choreography task. And those you can see here on the right. So here you can see one example of the choreography task. And the choreography task specifies a lot of things. So on one hand you have an initiating participant, which is always a participant that has a white background. It's not a participant that is on top. You have a label for that task, for the interaction. And you have a receiver, or a respondent in this case, which always has a gray background. But we can also swap that, so we can also say that the shop has a gray background and the supplier has a white background, and then the interaction goes the other way around. So in addition, we can also specify message objects, but in the standard, they do not really have kind of semantics. So we can just note here what kind of message we want to say, but there are no clear semantics in the standard. However, they allow us to specify two different types of choreography tasks. Because we have, on the one hand, we have one-way interactions, where we only send one message from one participant to another. But we also can specify two-way interactions, which you can see here on the right, where the initiating participant, which is that one with white background, sends a message to the respondent, and then the respondent sends a message back in that task. And this is also the reason why the respondent is not called receiver, because in the case of a two-way choreography task, the respondent is the receiver as well as the sender of a message. And just one fact, so for choreography tasks we consider it to be atomic, so that one interaction just took place then. Here for differentiation and for reference also guided collaboration diagrams. Just as I mentioned here, when we have one-way interaction, we only specify one message element or no message element for the initiator, and this corresponds to a single interaction from the customer to the shop in this case. And for two-way interactions, we have a message element for the initiator. Maybe do not have to have that, but we do have to have a message element for the respondent. So this then indicates that there will also be a message that's sent back. But in fact, this is notation is only syntactic sugar, as we could also write two separate one-way interaction choreography tasks that just illustrate the sending of the two messages. So here one for this interaction and one for the other interaction. Alright, so now that we have choreography diagrams, we can represent the interactions between the shop, the customer, and the shipper in a much more straightforward way. So this is not the complete choreography that I showed you on the slide 9 in the collaboration diagram. It's a simplification, but still you see that it's like a nice line on interactions. It's easier, simpler to follow than considering interaction models. And this also corresponds to the definition of choreographies, where we really want to have the sequence and definitions for the interaction flow. Any questions on notation of choreography diagrams and choreography tasks? Then I would continue with next question. So now that we can specify how the interaction should take place, the question would be, how can we ensure that the interactions that we specify also take place in the way we specified it, since we are in a distributed environment? So compared to process orchestration, where we just internally and within one organization run a process and have full control on when to execute what, in the process choreography, we want to merge the behavior of different orchestrations. So like every participant involved has their own process orchestration and has full control over their process, but no control over the processes of the others. So how can we make sure that the overall behavior is then still correct and works? And for that, we have the property of control flow and possibility in process choreographies. So, as I just mentioned, in process choreographies, we do not have that one single instance that can observe the entire behavior and can control the entire behavior and orchestrate that, because we distribute the behavior among all collaborators. So we do not have some central control at the same orchestration. And all involved participants instead only understand the process execution state and everything that happens from those visible, publicly visible tasks. So only from interactions, from sending and receiving messages. So to enforce the behavior, all participants need to work together, and we need to have a design of a choreography that ensures that all participants know when they are responsible to receive or send a message. So the responsibility is split among all involved participants. And for that, there is a property that is also used in distributed systems, which is called realizability. And it's defined in a way that an interaction model, which is a choreography diagram in this case, is realizable, where we can have a set of role projections. And the role projections is in fact just a public process of one of the participants that collectively can implement the entire behavior that is specified in the model. And now I would ask you, what is your feeling on this sequence that is snippet out of the choreography I showed you? Would you say that this sequence can be realized by different disciplines? So first we have the shop that hands over the parcel to the shipper. Then the shop sends an invoice to the customer. The customer then settles that invoice at the shop. And finally, the shipper can deliver the parcel to the customer. Okay, maybe with that definition, it's not that easy, but in the end it will be easy. So the simple answer for that is no, it's not. And the reason for that is that we cannot construct role projections or public processes that can ensure the constraints that are defined by the program. So here we have the constraint that a parcel can only be delivered when the invoice is settled. However, the settlement of the invoice is just done between the customer and the shop. So only those two can observe the interaction between the two, and the shipper cannot know when this took place. And this is also evident when we try to model this with a collaboration diagram. But in the collaboration diagram, it's actually, I would say, harder to spot that this issue occurs, because the rule of thumb for realizability is just that we need to check whether the initiator of a choreography task is just involved in the previous task, which applies to also gateways and stuff. So here, the shipper cannot know when the shop received the payment from the customer, so the shipper does not know when to deliver the parcel. So how could we fix that in that choreography? Do you have an idea? If not, it's fine. So the answer is actually quite simple. In order to ensure that this works, we simply need a synchronization task. We need to inform the shipper that the payment now was received by the shop, and then we add this additional task, and now the shipper is involved in the previous task, and we can continue with that approach. So the rule of thumb is that you look at the previous task, and you can ensure that you're adding those synchronization tasks for that. Now that we know that, what would you say about this set of code, which involves parallel behavior? So here we have the same as in the beginning, but now we have confirm payment in the deliver parcel, which we introduce here. Like we introduce the confirm payment, and we already have the deliver parcel task. And now instead of having them sequentially, we're having them in parallel. What would you say about this practice? Is it realizable? Anyone? Right, it's the same problem as before, because we cannot implement the complete behavior of the choreography, since it's not possible that the shipper can deliver the parcel after the customer settles the invoice before the shop has confirmed the payment, because again, the shipper doesn't know when this happened. However, still, it would be possible to find some execution that would match the semantics of the parallel gateway in this case. Because what we could do is we could simply say that we implement our processes in a way that we always first confirm the payment, and when the payment is confirmed, the shipper knows that the gateway was enabled, and so the invoice has been settled. So the shipper knows that he's free to go for delivering the parcel. So the fragment in itself is not realizable, but there is a more relaxed property of choreography diagrams, which is called local enforceability. And local enforceability, in fact, just weakens a bit the definition that we had for realizability, because for local enforceability, it's just sufficient to have a set of role projections which only enforce the model's constraints. So the difference is that we do not have to support the complete behavior. So we do not have to support that after sending an invoice we can choose both tasks, but we need to have some realization of this choreography that does not violate any of the constraints. And if we always confirm the payment before we deliver the parcel, we do not violate the constraints of the model, because that's allowed actually by the parallel gateway. So we could implement this choreography in the way we already discussed, which allows us to enforce the constraints of the choreography, but we do not cover the complete behavior. Still, local enforceability is a sufficient property for choreographies in order to show their correctness. However, local enforceability is not only applied to the sequence of activities, but also to decisions. Because decisions now have some kind of an owner, compared to orchestrations where decisions just take place because the process engine has all the information. The information might be now shared or like distributed across the different collaborators. So not everyone knows everything, and not everyone is allowed or entitled to make some decisions. So here Latlife defines the ownership of choice in the way that the owner of the decision is always the participant that has enough information to enforce it, which sounds straightforward but doesn't give us much information, so I'll have some examples for that. And the first example would be the event-based gateway that is supported by choreography diagrams, which allows us to have a decision. And the semantics of that gateway is that the first event, so because it's event-based gateway, or interaction that occurred after the gateway decides on which path we need to follow. So in this scenario, the customer first sends an order to the shop, and then now either the shop accepts that order and rejects that order, and only one of those two tasks can impact process behavior, because once the order is accepted, the shop, at least in this snippet, cannot reject it anymore, because then the decision was already made. And what's special for event-based gateways is that only one participant owns the gateway. And there are also some constraints. One constraint actually. And the constraint is that either all initiators or all respondents must be the same for all tasks that follow the gateway. We see why. So this is a simple example where the initiators as well as the respondents are the same, so we are fine with that. And if we would translate that, we of course would also need some kind of decision here for the shop to send the message to the correspondent, and then also to receive it on the end. Now I have a question for you. Which kind of gateway would you use to implement both of these processes? Because for event-based gateways, it's a bit special. Do you have a guess? An idea? Guess is fine. So we have all event-based gateways, we have exclusive gateways, parallel gateways, and that's enough. Okay, I can solve that. So in this case, if you consider that the owner of the decision is with enough information to enforce it, only the shop can actually decide on how to accept or reject the order that was sent by the customer. So the shop in itself must make the decision and decide on which path to follow. And the customer, since the customer does not know whether the order is accepted or rejected, the customer cannot have an exclusive gateway, because the concept of exclusive gateway is that you make your decision based on data that you have available. But as a customer, you do not know how the shop decides. So here you need to react to the decision of the shop. So you need event-based gateway, and in order to react on the corresponding decision by the shop. Similar case when we have different receivers or respondents. Also the shop again makes a decision, and then either the customer is being informed or the supplier is being informed. So here we have setting the order the same, but on the other end we have an example where the shop orders some parts from the supplier. And in the last case that's supported, we can also have a scenario where the respondent is the same, but the initiators are different. And in this case, the decision is not enforced by the initiator, but by the respondent. Because in this scenario, the supplier sends delivery date to the customer, and then the customer still has this chance, a small window, to cancel the order at the shop, or the supplier just notifies the shop that the parcel is in delivery, which then leads to the fact that the order cannot be cancelled anymore by the customer. So depending on which message arrives first, the path is followed. So here on the right we see that both send the message and the shop needs to react, but is still the one who can enforce how to proceed. Because only the shop knows which message was used or they received first. So, questions regarding local enforceability, ownership of choice, realizability, or is everything quite clear? That's good. Coming to the last gateway, which is the exclusive gateway, and already told you that this exclusive gateway deals with data. The concept is that in this gateway, it's not mandatory that only one participant takes the decision, but all have to take it. So all have to make a decision on how to proceed based on their available data. And this leads to some additional constraints. Because in order to all participants deciding like the same way, on the one hand, all participants involved first, of course, need to have received the data on which the decision is being made, and they also need to have the same understanding of the data, so that all by themselves can make the same decision to continue the execution of the choreography. And this was always a bit tricky, because even though we can specify those message elements, they do not have some semantics, so they are not real data semantics that we can specify in a process choreography. And we cannot be sure whether at this point, when we want to decide on whether the tracking is required, whether the shipper, the shop, and the customer first of all have all the data that they need to make the decision, and whether they also, based on the same data, make the same decision on that data. We just don't know that with that one alone. And so here you see that only looking at the control flow perspective is not sufficient. We also have to reason a bit about the data that is available and make available for the participants. And this semantics for that are unfortunately lacking. So we somehow need to introduce that to choreography diagrams. And this will be done in the next section. So if there are still questions for the previous section, then you can ask them. If not, then as well, then I can continue with data and process choreographies. So to start that, I have another snippet that relates to our choreography that we have. So in that snippet, we see that a shop sends an order to a supplier in order to order parts. And then in parallel, we need some documents for that, because the supplier needs to ship them. Maybe it's international shipping. So on the one hand, the supplier wants to be sure that the freight can be imported. So they need, the shop has to show some kind of import permit before the supplier then hands over the cargo to a carrier. And when the supplier hands over the cargo, the carrier creates a bill of lading and sends it to the supplier, which is something like a document of ownership on the freight, on the cargo that is being delivered. And it's also important to verify in the end that the shop is then the new owner of the freight. On the other hand, we have the supplier that needs to forward the bill of lading to the shop so that the shop then in the end can claim the freight when receiving it. And the shop then also registers the import of that good at the customs so that the customs can create their import permit for that. And when we look at this, while this is completely fine regarding control flow enforceability, we have some issues considering the data. Because at this point, when we are here after the parallel gateway, the supplier is obliged to send a bill of lading, and the shop has to send or provide an import permit. However, both documents are only issued in tasks that are executed after those tasks. So again, we have some kind of a deadlock situation for that. And so we somehow need we have this challenge of data awareness. We need to be sure when are people aware of which data they have to send. Next, we have a problem regarding data dependencies, because with that notion here, we really don't know whether this order refers to the same order as here, for example, and we do not know whether there are some dependencies for creating some kind of data, for example. So is it required to have an order on the customs side in order to create the import permit and then send it back? And finally, we have the third challenge. That's called data consistency, and this refers basically to the challenge that I already discussed a bit for the data objects, the data object for the exclusive gateways, where we, first of all, again for data awareness, need to make sure that all participants have the data that is required to make a decision. So here we have a decision on whether customs inspection is required after the carrier informs the shop that the container has been arrived, and in the case no inspection is required, then the shop can just request the container, and else the shop has to declare customs clearance. And the first question, of course, is whether all those participants that come after the gateway have information for that decision, which is the first question here. The second is regarding data consistency. Do they all have the same understanding? So will all decide the same way, which is still not clear. So we have in total 3 different challenges for process choreographies when we consider the data perspective in that. Are there questions regarding the challenges? Yes.
Could you briefly explain the third challenge? I think I didn't get it.
Yes, sure. So the idea is, regarding first or the second condition?
The second.
The second condition. So the idea is that so in BPMN you may not implement decisions based on, for example, based on decision tables, or you have some internal logic on how to decide based on the input data. And in this case, it's only clear what are the outcomes. It's not clear what kind of data is being used in order to make a decision. And it's not clear whether every participant involved has an implementation of making that decision, so that having the same data, all participants make the same decision in the end. Does that answer your question?
Yeah, I think so. Yeah.
Great. Exactly. So we have these 3 challenges. Another question? Okay, great. And in order to address these challenges, we want to extend the semantics of choreography diagrams. In order to do that, we want to use supplemental models. Because the idea is that, that we still want to comply to the choreography standard, because that's already defined and can be used. And if we just supplement this with additional models, we still comply to the standard. We can still use existing modeling tools, and it's easier to integrate this then into the systems. And the idea is to have two different types of models that then extend semantics of choreography diagrams. We have them. So on the one hand, we have a shared data model that specifies which kinds of data can be sent in a choreography. And on the other hand, we have a distributed object lifecycle, which we'll talk later about. So it relates a bit to the different states. For example, also data objects can have in a process. It's a similar concept, but just not for data within a process, not for data that is being exchanged between processes. So regarding the shared data model, the basic idea is here that in addition to the choreography specification, we also have a data model that is known by all participants that are being involved in that choreography, and they also all have the same differences on that. And the data model specifies different types of messages that can be sent in the choreography. So here we could also specify which kind of attributes, what could be the content of an order message that is being exchanged. And in addition to that, the shared data model also specifies relations between different messages that can be exchanged. For example, an import permit must always refer to some order that is that needs to be then it has been sent earlier. And the idea is that we then can create instances of those classes, which are then referred to as message objects, similar to the concept of data objects within processes. And these message objects can then be exchanged between the processes. And they can only be shared by choreography tasks that have an annotation on the message element. So here, an order message object would be sent from the shop to the supplier in this particular part of the task. And this also ensures or adds a constraint to that task, because now also the task requires that the shop must be aware of a message object of the type order in order to just execute the task. In addition to the shared data model, we also have a distributed object lifecycle. So who's familiar with object lifecycles in general? Okay, that's great. It's the same concept with a little addition. So the idea is that message objects can also have states. And the idea to do that is that when we add states, we can refer back to existing data that has been exchanged. So alternatively, we could just say that every interaction would be a new type of message that's being exchanged. But if we have some interaction where we, for example, hand over a document to someone and the document is then signed by the other one and sent back, and it's not a different object, but it's the same object in a different state that has been updated during those interactions. And this is the idea behind message objects and states. And now states are represented as those cycles, and state transitions are indicated by those arrows. The first arrow coming from nothing indicates the creation of a message object of this type. And the idea now is that when we have specifications for all different types of messages, so for all message classes, which states instances of those classes can be in, and of course from which state can be traversed to what other state, and which of the participants is allowed to make that change. So, for example, only a shop can create new message objects, and only the supplier can confirm it in this simple example. Could also deny it, but it's not modeled here. So message objects really need to be exchanged in this case in order to be manipulated by the different participants. And similar as the classes, they can also be annotated to the message elements that we have here. Exactly. And this is an additional constraint. So now not only the shop needs to be aware of an order in order message object, but this message object also has to be in a state created. And correspondingly here, the supplier has to return it in a state confirmed. So similar to the last presentation, so the last lecture, we also want some formal semantics. So we again make use of the nice concept of patronets. Actually there's already some kind of formalization for chorographic diagrams in general, which was introduced by Gero Decker, also former member of this chair and founder of Scenario. This type of pattern is a bit different because it includes some additional information on the tasks, on the transitions. So here you can see places as usual, also tokens, arcs, and here we have one labeled interaction transition, which basically behaves the same like a normal transition, but we enrich it with information on the sender and receiver of a task, and we also assume that we only have one interaction, so a one-way interaction for one labeled interaction transition. So if we want to model this two-way choreography task that we see on the left, we need to have two transitions for both ways of this interaction. So in order to also add the data and the data constraints to that now, we need some additional places. So for every participant that is involved, we create a data place or message object place basically for every class and every state this class can be in. So here we have for the shop two order message places, and for the supplier we have the same. Then we need to connect it to the task. So since we say that the shop, in this case the initiator, needs to be aware of the data that's being sent, we of course need to check whether a token is in place whether a token is in place in order to then send it to the supplier. In addition, when we have some kind of an update, when we receive a message object in an updated state, for example here we have an order in a state confirmed, and send it back to the shop, then the shop needs to reset the current state they have on this message object, and which allows them then to update the state to confirmed. But of course something is missing here. We also need to have the data, local data management, which is specified by the distributed object lifecycle. And here we introduce one new place and two new transitions. So I think the bottom one is quite clear. The supplier is allowed to change the state from created to confirmed. And the top one ensures that every participant only has one instance of class. And this is important because when we then later talk about consistency, it's important that each participant has only one instance in one state of each class, so that we can be sure that we talk about the same instance when we make a decision of those on the structure. Because we could also say that the shop now creates a huge amount of orders, and then we do not know which order we are talking about. So we are limited, in fact, here to one instance per choreography, similar to data objects and processes. So we have one init place, which is initialized in the beginning of the choreography, and then shop can create the order. So the idea is then, when we want to tackle data awareness, that we always ensure that the sender is aware of the data that's being sent. So when we have some token replay on that, we see that here the shop can initialize an order in state created, then sends that to the supplier. The supplier can then locally change the state to confirmed. So here we have some inconsistent state, but then we can synchronize that state with the final task in order to have a same loop for participants. Questions on that? Or it's straightforward? Great. So, the next challenge was regarding data dependencies. So here we already introduced parts of it because we already consider the distributed object lifecycle. So we see that we have those dependencies for which participant is allowed to do what, because only the supplier can change the state here. And also the dependencies on which state transitions are allowed. And also for the creation, we have this construct I just explained. In addition to that, now we have to change the example a bit. We also have to consider the relations that we have for the data model. And for that, in this example, we have shop sending a confirmed order to the customs, and then the customs responds with an import commit in a specific state. And here on the bottom we see that we need one order in order to create an import commit. We can represent that on the right side that here we have the initialization of an import commit, and we can only initialize it or create it when we are aware of an order that is being sent by the shop. So when we have some token replay here, first the shop sends their order to the customs, which is now aware of the data. Then the customs can create the import commit and send it to the shop, so that now both are aware of the order as well as the import commit. Right, and finally, we have data consistency. And for data consistency, this is now quite simple. So because in the originally we had this mapping from the exclusive gateway to the Petronet, where we introduced the silent transitions, which represented the decision that has been made. And now we can constrain that every participant needs to be aware of the data that we can now clearly specify on the arcs that we have. So here we require that import commit needs to be in a state accepted in order for the shop to just do already request a container, and after that the shop needs to apply for customs clearance if check is required for the import commit. And we can simply add this as extensions on the decisions, so that we require that either all involved participants are aware of the one state or the other, and otherwise this gateway cannot be enforced. So here, in order to enforce that, in order to have a complete run of the choreography, we can ensure using Petronets that every participant is aware of the data, that we have data dependencies in place, and that they work within the choreography. And finally, that for decisions, we can ensure that there's data consistency among the participants, because otherwise we would run into a deadlock.
Can I ask one question?
Yes.
I mean, probably super simple to answer. Like the line that's crossing the arrow under import commit accepted. What does it mean?
It's actually the default path. So
That's the default path.
processes can specify which behavior is expected, and this helps you to indicate that. But it does not impact
I get it. Yeah.
the semantics of that.
Because I couldn't see how it's translated, so that's what I was wondering.
Yeah.
But here you're always assuming that all three end up with the same decision, right? Because otherwise you're blocked.
Yes. So in the data exchange that took place before we can come to this decision, somehow we need to come to a state that all three participants in that case have the same understanding of the message object import commit. Yeah, exactly. Only then we can execute this interaction, else we would run into a deadlock, and then we could use that to analyze at which point we missed some interaction. For example, we missed to send some data to a particular participant that's involved.
But if one accepts and the other two require a check, then
Yes.
yeah, in that case.
In that case, we discovered an inconsistency, and
Alright.
this must not occur when we come to this gateway. So when we are at the point of this gateway, we need to make sure that always all participants have the same view, and first of all have the data and have the same view on the data. If that's not the case, then we have some mistake in our model and need to change it there. So, all right. If there are no further questions, then we are ready at the part of future directions and also the summary. So now that we have data in postchorographies, we are not in NAND because, of course, we similar to public and private processes, we also need to make sure that the specifications that we made here can also be implemented in the private processes of all the different collaborators. And then we also need to make sure whether the data management that is then being carried out locally also corresponds to the data management that we specified in the choreography, so that there are no conflicts between the private implementation of a process and the public design using the choreography diagram, for example. Then we currently only looked at very simple data management in choreographies. So there could also be much more complex data management if we also consider multi-instance tasks or multi-instance participants. Because currently we assume that we only have one participant for each pool, but it could also be possible that we would have a set of suppliers, for example, and we ask each of them for an offering, and then we need to decide which supplier we select and which offering we then use in our data. And finally, we could also have multi-instance data because when we, for example, send or request an offering by multiple suppliers, we just create like one request and send it to all different suppliers. Then every supplier does something else, maybe locally, and we get a list of message objects referring to the initial sent message object back, and then we need to figure out how can we work with the data. And in that case, we will probably need to escalate the semantics to color patronets, but I won't introduce them in this lecture. This will, I think, then be done by Anu. Would you take care of color patronets a bit?
No.
Okay. Then you do not have to learn it for the exam, and it's even better. All right.
Sadly not.
So when we have that, we could derive some general enforceable property for data, similar to realizability and local enforceability that we have for the control flow layer, but now also considering more complex data management. And then based on that, we could also use the data as a link between different choreographies, where we, for example, could define a choreography for the customer and the shop, and one choreography for the shop and the supplier. And based on their data conditions, they maybe trigger each other or impact how other choreographies follow. So we would have a more declarative and more holistic view on how different interactions also impact each other based on the data that's being exchanged. All right, so we worked quite fast today. So to summarize what we've learned, I talked to you about process choreographies and motivated on why it's required to find them and how it's possible using collaboration and choreography diagrams. Then how in collaborative scenarios and process choreographies it's important to ensure that what we define is also correct, can be enforced, since in scenarios the responsibility for execution is distributed across all the different collaborators, and based on the properties of realizability and local enforceability, we can ensure that we can detect issues from the control flow perspective. But not only from the control flow perspective, we also took a look at the data perspective, and we identified challenges of data awareness, challenges of specifying data dependencies, and verifying data consistency during execution based only on the model. And in order to address that, we introduced additional models, the shared data model and the distributed object lifecycle, and combined them with choreography diagrams in order to have a more holistic view on how data is being managed and being exchanged in choreographies. And then we and also data enhanced interaction patronets had been introduced as formalism for the combination of those different concepts. So I came in for today. So are there some questions on the topic, the things you saw?
Maybe if you could just explain local
Local enforceability?
enforceability, yeah.
Sure. I can do that. I talked to you about realizability as one property, and realizability enforces us to that we can implement the complete behavior that we specified in the model. And the main difference between realizability and local enforceability that we have here is that local enforceability is a bit weaker. So here what it requires us is that we can implement the behavior, but we do not have to implement the complete behavior that is allowed by the model, but it's sufficient that we implement some behavior that does not violate any of the constraints that we have in the model. So here we cannot implement an interaction where the shipper delivers a parcel only after the customer set its invoice to the shop, but this task hasn't happened. But if we execute in a way that first we execute this task, then this task, and then this task, which does not violate the model, then it works. But it wouldn't work the other way around.
Which is not complete because you cannot deliver the parcel first and then confirm it.
Exactly. So we can, because the parallel gateway allows us to execute what follows in any order, and this is just not possible in this example due to those constraints. This is the main difference. Thanks. Yes?
I have a question about the axiom. How would, I mean, it's a bit hard for me to understand how this topic might be touched in the axiom, actually.
Where? Did not understand where it is touched.
In the axiom.
The exam.
Yeah.
Okay.
At the end of the lecture.
Yeah.
I mean, just so that we understand how to take notes or how to remember these things. Should we, for example, also really understand how these different transformations to patronets work in dev? Is that something we, for example, would also have to execute? Because we have been talking about this a lot, right?
Yeah.
And kind of an obvious thing to think about. And then generally also these concepts such as local enforceability. But these things we should learn for the exam.
So yes, this will be relevant. So what we covered here will be relevant, and in the exam. So first of all, the quizzes should prepare you to should hint you already into a direction of what could be relevant for the exam. And it can also be possible that in the exam you are tasked to, for example, translate a simple choreography diagram to a collaboration diagram, or also a choreography diagram to a patronate representation, or when we refer to the last lecture, also input-output set combination of a single task into a patronate. So this can also be all part of choreography, of an exam. And and those properties that have been introduced and also defined should also be should be relevant.
I'm just trying to understand which level of dev this would be.
Yeah. So already also not only on the high level, the concept level, but especially for when we reintroduce some techniques on how to figure out specific things, then this could also be part of the exam. For example, given a choreography, is it locally enforceable? Is it realizable?
Makes sense. Okay.
But the quizzes should help, hopefully. All right. Are there further questions? If not, then thank you very much for your attention, and then we can close the session for today. So I will prepare another quiz. I hope that I'll manage it until Wednesday morning. If not, then it will be the latest on Wednesday evening.
Have a Moodle page, or it did have?
It does have.
Oh, okay. It was another one that didn't have like process mining, I think. Okay, all right.
Up to you. There will be 2 quiz discussions. So first of all, if you want to visit the Moodle, okay, perfect. So there will be 2 discussions, one at the end of this year and one at the end of the semester, so the very last session. And there I will pick out some questions that maybe have some difficulties, and then never will discuss them a bit, so that we will use the page.
Is it like a form of exam?
Not already. So it's an intro, you don't get grades, it's just for you the preparation. Yes. Yes. It will be an oral exam, but we will fix a date. Yes. So it will be with the professor, and I will attend. So I will make sure that only stuff is covered. Is covered is also asked. And I think we will discuss it in a date soon, because we wanted to wait until tomorrow, because tomorrow is the registration deadline, and then we will fix a date for the exam.
Is there like any other material I can look besides like the slides? I'm not sure.
Yes. In the first slide, in the course introduction, you can find here, this page, where there are 2 OpenHPI courses. So if you already used OpenHPI, exactly.
No, I haven't.
Okay, no worries. So that you can then visit them, and you can just look through them. I have made some recommendations.
These are like these are like prerequisites, let's say, about this course, or just the information related to like.
So the idea of this course is not to discuss the fundamentals, but to go beyond that a bit, go more deep into some specific topics. So this course here is basically about the more fundamentals of VPN, introducing the notation, introducing some of the concepts that are important for that, and also, like, on the other hand, here is a course on process mining. But if you visit the process mining course, then maybe you don't need that.
Okay. I have now already. Let me check. I'm not sure actually. I'm still fixing my schedule, and I've been attending like, oh, it's process mining. Yes. Okay. Yeah.
Then you probably don't need that, because process mining, I think, will also only be part of trends